Hi, it's Eric. Today we're going to talk about the right hand rule, which is a way of understanding the UCS or the user coordinate system. In CAD, we have what's called the world coordinate system, which is for a lot of people, the way you draw when you're drawing in a plan view. You're always having the origin at 0, 0, and the X going to the right here and the Y pointing up. When you draw in 3D, your X and your Y can be repositioned based on what you need to model in 3D space. So the right-hand rule is if you take your thumb and index finger and point to the right, and then take your middle finger and point it straight out in relationship to your thumb and index finger, that is essentially a good way to understand how the X and Y and Z relate to each other. That relationship never changes even if you are to reposition your X and Y in some other plane. Let's move over this way. I've created a 3D hand to sort of explain this a little bit further for you. So here we have the X here, the thumb, and the Y here, the index finger. As you can see, it matches the UCS here. And then the Z is pointed straight up, which would be our middle finger. Now, as I said, in 3D, we can take this same orientation and manipulate it how we want. So in this example here, we have here is the X here and the Y here and the Z direction pointed straight out. For example, if I created a rectangle out here, and again, remember I'm still working in the world coordinate system, so my X and Y is going to lay flat, and I extrude this, let's say, let's go up 12 inches. So now we got this box. Now, if I wanted to work on this surface, my X and Y have to be oriented just like this. So the X is going here to the right, the Y at a 90, and then the Z is pointed straight out. So in order to match the UCS icon to what we need, we're going to establish our origin here first, and then our point on the positive X-axis and our positive Y value here. And what it's going to do, it's going to rotate our UCS so that our Z is pointing straight this way, just like what is shown here. We go to another example here. I rotated the X and Y plane so that the X is pointing this way and the Y is pointing this way, and then the Z is pointing straight out. In order to reorient the UCS, what I need to do is, again, type in UCS, choose a 3-point option. By establishing the origin here, as opposed to here or anywhere else, this will be the working surface. So by clicking here, I'll be working on this surface here. If I were to click on this inner corner here, then I would be working on this surface here. So we type in UCS, 3-point, we'll click this corner here, and our positive axis is going to be here, and our Y will be here. So now you can see, if you look closely, you'll see the Y here, the X here, and then the Z pointing straight out. If I were to draw a circle, just arbitrarily draw a circle here in space and click and give it a radius, let's say at 8. If we rotate our model, you can see that the surface aligns with my origin. It located the circle based on the origin or aligning to that surface. Now, if I were to do the UCS again and put my origin here on this corner, again, my positive direction is going to be this way, and my Y direction is going to be this way. Now look at the Z is pointed out. Again, in relationship to the Y and Z, it's always pointing the same direction. And another thing to note is this is the positive direction of the Z, and this is the negative direction of the Z. So if I were to draw another circle, let's just draw a circle out here arbitrarily again, and then rotate it so you can see the alignment. If I were to extrude this circle, the EXT command, I'll press enter. If I go in a positive direction, let's say if I type in 12, it's going to follow this direction here. If I go in a negative direction, it's going to go this way. Let's just press enter. You can see it's extruded it based on this direction. Now let's undo that and extrude it again. This time we'll extrude it in the negative direction. So a negative 12. As you can see, it's extruded it that way, 12 the opposite way, extruding this 12 inches. While we're working on this, let me just show you one more example. Let's say if I wanted to draw a pipe coming from this surface here, I'd have to reorient the UCS so that my X is going this direction and my Y is going this direction. So let's do that right now. So UCS 3 point, my first point is my origin, and then my X and my Y. And as you can see, it's reoriented our X and Y with a Z pointing straight out. Now, if I were to draw a circle, and I'll put the circle in the midpoint of this surface here by using the M2P command, which is a shortcut for mid between 2 points. I'll click here, and then draw my circle at, let's say, 1 inch. Now again, I'm working on that surface there. If I type in EXT, L for last, or the last entity drawn, that's going to select my circle, and then I enter. And to extrude it in the positive direction to match this Z here, I'll just type in 12 inches. It's going to draw my pipe in the Z direction based on I oriented the X and Y. Now, if we ever want to go back to the world coordinates, we just type in the UCS command and then W for world. And as you can see, the UCS has moved from here to here. And from here, we can go into our top view to work in our typical plan mode. So I hope this video has been helpful. It's explained a little bit more about world coordinate system and the user coordinate system, and we'll see you in the next video. I'm also using a AutoCAD alternative called AutoCAD, and we're in our 2025 release now. If you have AutoCAD, maybe you'd like to have a look at that if you're interested in a alternative. AutoCAD's native file type is also DWG, and the two programs can work side by side.